So I'm delighted to say hello to Dr. Nicholas Frerich, colleague, consultant at SCHUMANN. So I would like to hand over, and everybody's now curious to hear how to handle AI in this credit risk management context. So
thank you.
To you.
Artificial intelligence in credit risk management. Application, challenges, and visions. So to talk about this, let's start with a brief introduction and look at some applications. AI, of course, is a giant topic, and it cannot be comprehensively explained in just 15 minutes. But to better understand it, you have to understand that there are two big subgroups of AI or machine learning. There is supervised learning and unsupervised learning. In supervised learning, there is a training set of data where you know the result in the past, and you train the machine to understand the complex relationships that led from the input to the output, so that in the future you can use this model to predict outcomes based on the data you have. Unsupervised learning, on the other hand, is when you don't have a set of known outcomes in the past, you just have a set of data, and you have your machine find similarities, find structure. This is very helpful as it can point you towards the right direction and can give your analyst a starting point to find groups within your data. Now, this is done with a whole lot of different techniques. There's regression systems, there's support vector machines, neural networks. On the other hand, you have clustering techniques, mixtures, or structuring. And all of these seem like a lot, but let's have a look at what you can actually do with it. The range of things you can do with neural network is huge. There's things like customer attention, forecasting, optimization, but also structure discovery, customer segmentation, or visualization, which is very, very important. So now that you had a brief introduction into what is possible with AI, you have to understand that in order to actually use it, you have to look at not just the modeling, but the whole data analytics and AI pipeline, which consists of data preparation, data modeling, and data evaluation. What does this mean? Well, let's have a look at an actual example in terms of credit risk management. This is one pipeline that could be used. The data you get from financial statements, then you model it using neural networks, and you evaluate your result by assigning credit ratings. Of course, this has been implemented in the past at SCHUMANN. Now the question is, why is this not used more? To understand this, let's have a look at some challenges and some visions on how to overcome these challenges. I already showed you the data analytics pipeline: preparation, modeling, and evaluation. To understand what challenges are in the way of this, let's have a look at one challenge for every 3 of these fields. For data preparation, we're going to have a look at data time lag. Data modeling, we're going to have a look at data usage. And for data evaluation, we're going to have a look at AI explainability. Don't worry about the details now, I will go into them during this talk. First off, data time lag. What is data time lag? Let's assume you have an automated AI system that decides credit application based on the data that is accessible to it. In 2016, your system got a credit application by one of your customers. What kind of data can it look at? Of course, there are financial statements. There's a financial statement from 2014. There's also financial statements perhaps from before that. And the system can look at each of these financial statements alone, but can also do analysis of the trends between the statements and then make a decision. Let's say, in this case, it was approved. Next, every year following this, you have the same process. Every credit application is approved based on the financial data from the years before. And now we arrive in the year 2021. Is it still reasonable to apply this process in order to have your AI approve or deny this credit application? As we all know, in late 2019, the pandemic really hit. Now, it is very reasonable to ask, is this data from before the pandemic still a reasonable starting point to assign or decide a credit application in this year? There are some companies that stayed roughly the same during the pandemic. Some companies lost a lot and some companies gained a lot. And it's not clear which of these your customer is. So how can the system get data that does not lag behind in time, but reflects the current events? For this, we're going to have a look at data from social media. Social media platforms like Twitter, LinkedIn, or Xing reflect the current events where people can really give their opinion right now or give data right now. To understand how this can help us, let's have a look at an example using Twitter. On Twitter, a lot of people can give their opinion or give statements about a company or concerning a company. So what you can do is you can actually look at all the tweets in a given time frame that mention a company, and you can categorize them using computer models into, are they positive, are they rather neutral, or maybe are they negative? Then what you can do is you can analyze the shift of this overall sentiment over time, and it has actually been shown that insolvencies are preceded by a downward shift of this sentiment. For example, we can have a look at Praktika GmbH. In July 2013, went insolvent, and right before that there was a sharp drop in sentiment on social media. Of course, things like targeted social media campaigns can influence this, so you have to be aware when using this method that maybe you need some clearer data or at least additional data to enhance your prediction. For that, let's have a look at examples using other social media platforms, in particular career social media, such as LinkedIn or Xing. Now, a lot of data is freely shared on these platforms, which is clearly connected to businesses and careers. Someone maybe leaves a job at one company, goes to another company. These are hard data points. Maybe when posting the new job description, they also tell you what kind of job they have at the new company. So there's additional data hidden in there, which is not a sentiment, it's not an opinion, but it's just a hard data point. So in fact, it is not as easy to manipulate this as, for example, Twitter data or data which is just based on sentiments. In detail, which data is possibly relevant for credit risk analysis? Well, there's the behavior of employees on the given platform. There's the employee turnover rate, which can be extracted, as I just told you, from job postings, for example. There's also the management turnover rate, which can be very interesting when looking at this. And there's a lot of different other data which is still hidden on there, which is why this is an ongoing research project at SCHUMANN right now. Let's have a look at another example of a challenge. For this, we're going to have a look at data usage. According to different studies, approximately 70% of data goes unused. There's also studies suggesting that up to 99% of data goes unused, so this is still a conservative estimate. Why is this the case? Well, let's look at what kind of data is not used. This is unstructured data, or text data, or image data. So this is data that cannot be easily assessed by a computer. Maybe you need a human to understand this data or put it into form before you can hand it to the computer. How can we change this? The solution here, or the vision going forward, is to use new advanced models, such as, for example, encoder-decoder systems, also known as autoencoder systems, that are able to do image or text analysis and detect features of your data. What does this mean? Well, let's, for example, imagine that you have a picture of a red sports car. Now, if you just feed this picture into a machine, it's just a bunch of pixels. Maybe from the amount of red in the picture, you can somewhat estimate that there's a prominent feature on the picture that is red, but the computer cannot understand this. However, using these encoder systems, it is possible to detect the features, car, sports car, red, different kind of things that are on the picture, and put them into a machine-readable state. Also, there is natural language processing, of course, which is very important. It is already used to understand and generate text, for example, in AI chatbots. However, going forward, there's also studies using natural language processing to detect the meaning of textual input. And of course, this is very interesting because a lot of data out there is written data, and it is highly desirable to be able to filter this and get information out of it quickly. For example, let's have a look at management reports. Management reports, there's a lot of data in there which cannot be put into numbers easily. However, there are still things that can be extracted from this, like is there positive or negative wording, more or less of one of them? Is there hedging vocabulary? Is there a lot of passive forms instead of active? But also other stuff that is not as easily seeable by humans, like is there clear changes in the structure compared to earlier reports? How good is the readability of the report, and much more. And this is something, if you have a lot of textual input, your analysts will spend a lot of time reading it. But if you have an AI categorizing this for you, you will save a lot of time. And of course, this is also an ongoing research project at SCHUMANN. For the last challenge, let's have a look at AI explainability. What does this mean? Well, imagine you have a customer who hands in a credit application into your automated AI system, and the credit application is denied. Now the customer asks, why was my credit application denied? Using an AI to help make these decisions, or even make these decisions for you, might be highly accurate, but it's also traditionally a black box. It does not tell you why it made a decision, just what decision it made. However, explainable credit decisions are highly desirable, both for your customer and for your credit manager. For one, customers have a right to an explanation, at least in Germany and other countries. But also, the explanation can be an important factor in identifying new risks early on. Luckily, modern techniques can be used to retroactively explain the AI's reasoning. These so-called explainers can be roughly broken down into two groups. There's so-called statistical explainers, which are used for numerical models, such as neural networks and others, and they can interpolate locally or globally, that means for a single decision or for the whole network, what kind of parameters will influence the outcome in what degree. So for example, let's look at an example here. You have the input parameters A, B, and C, which are fed into your model, and then they give you a result. For example, application denied or approved. Now you want to know why. Now you can feed this whole model, the input, the model, and the result into your explainer, and the explainer can actually tell you, well, parameter A was slightly positive, parameter B didn't really have any effect, but parameter C was highly negative for the outcome. So then you can come back and understand that parameter C is what really made this decision. Furthermore, there is attention modeling. Attention modeling is a different form of explanation, and it is used for attention systems, so encoder-decoder systems, for example, which I talked about earlier with the red sports car. What do? Well, they are used, for example, in text analysis, natural language processing, also in image analysis, and they show you which part of data or text have the AI's attention when it makes a decision. So this is a bit similar to keyword detection, where you feed beforehand, you feed a list of keywords into the system to detect, but it is automatic. You do not need to feed in some input list, but just when asking the AI a question or to make a decision, afterwards it will highlight which part of the input was the most important for the question. For example, if you just imagine you have the input, the dog is running over the field chasing a ball, and then you have the question for the AI, what is the dog doing? The AI's output is running, chasing a ball. Now you can retroactively go back and see which parts of your input had the attention of the AI when answering this question. And in the same vein, if you come back and remember our example with the red sports car, you could say, what is on this image? And it will tell you there's a sports car, and it will highlight the sports car on the image for you. Now, this is very interesting because It makes it so you can use the AI as an early warning system. You can have it filter through a lot of data for you, and it can, if it thinks there's something that should be looked at by your analysts, it can give them the part of data that needs to be looked at, but furthermore, it also tells them what exactly sparked the attention of the AI when handing it to them. So to summarize all of this, in order to properly use an AI in your project, you have to find the right application. You have to understand what challenges are in the way of the AI, and you have to utilize modern visions in order to overcome these challenges. Thank you for your attention, and if you have any questions, please feel free to ask them now.
Yeah, so thank you, Nicholas. Very impressive. Well, it's always great to look behind the curtains, look into the research and development, what Schumann is doing, what you are doing, and what the people around this question AI technology. So I think the impressive part here, from my view, was that there is a clear understanding roughly to have a flavor somehow, a short insight, what it's all about talking about AI. And our mission at the conference is not handling only buzzwords, rather than explaining what's behind that. But maybe a short question, and I know that is really difficult to answer. So people are asking, okay, when is a certain status for a product available in AI? Could you give us an idea what it takes in terms of time schedule to develop certain outcomes to have a certain product maturity then?
Of course, this is an excellent question. There's a lot of factors that go into this and that determine in the end how long it will take to implement a project, of course. I think especially with AI, it is important to realize that this is an iterative process. You can't just go, put your data somewhere, and expect that the first iteration will give you great results. You have to work iteratively, so it will, of course, take some time. Now, it depends on the scale of the project. It depends on maybe how fast the processes are within your company. So I would say, just a rough estimate, it will probably be at least 12 months or more to properly implement a project like this.
Yeah, and you explained that there is a certain dependency, available resources, but also, of course, relevant data and any prerequisite that you need for starting such a development. So, Nicholas, thank you very much for these insights.
Thank you.
Thank you.